Lesson 2-3 on histograms and percentiles. What are histograms? A histogram is a graphical representation of data in a data set, using columns to show how data is distributed across a set of intervals. Now, we've already done a graphical representation of data using a box and whisker plot. A histogram works a little differently. A histogram actually shows data using what more appears to be a bar graph rather than, well, a box and whisker plot. You'll see what it looks like in just a moment. Let's say that we had this sample of data here, all these data numbers. We don't know what the context is, but that doesn't matter. Numbers 5, 7, 11, and so on up to 48. Now, in order to visually represent this data, we're going to break up the number of numbers between these intervals. For example, between the interval from 5 to 10, we include 5 but not 10. So greater than or equal to 5 but less than 10. How many numbers in this data set fall within this interval? 2 of them do. So on our histogram, we're going to make a bar that goes up too high. On the next interval, greater than or equal to 10 but less than 15, how many numbers do we have in that data set? We have exactly 1. So we'll make ourselves a bar that only goes up 1 high. On the next interval, greater than or equal to 15 but less than 20, we actually have 5 numbers. So we'll make a bar that goes up 5 high. And we'll continue this process for each interval on our histogram. In the next interval, we have exactly 4 numbers that fall into place, so our bar goes up 4 high. Then on the next interval, we have only 3 numbers, so our bar goes up 3 high. And then on the next interval, we have only 1 number, bar only goes up 1 high. Now in the following interval, greater than or equal to 35 but less than 40, we have 1 number. But on the following interval then, between 40 to 45, we have no numbers that fall into there. So we won't use a bar for the interval between 40 to 45, but then between 45 to 50, we do have 1 more number that falls into place there. So here is our completed histogram showing us a visual representation of the frequency of numbers within certain intervals along our entire range of data. Now, a couple other quick vocabulary terms. Each of these bars is actually called a bin. In a histogram, it's called a bin. On a bar graph, it's called a bar. Same difference. Second, there's also an additional piece of data called a bin width, and that is actually the interval between numbers on the histogram. Second, we have percentiles. We discussed this a little bit before, but again, we'll just go over it. A percentile is a ranking of a value in an ordered set of data, giving the percent of data values below the given value. For example, going back to the exact same sample of data we had previously, within all these numbers, if we wanted to figure out, say, any particular number, where it ranks compared to all the others, we can use a percentile ranking. Let's study 18 for a moment. If we look at 18, there's exactly 6 numbers in that sample of data that are less than 18. So since 6 divided by 18, 18 being the total number of numbers in the data set, since 6 divided by 18 is 33.3 repeating, that means 18 would be in the 34th percentile. In case you ever do a division problem like that and you get a number that's a decimal, to find the percentile ranking, just round up to the nearest whole percentile. So 18 would be in the 34th percentile. On the other hand, 21 falls exactly within the 50th percentile because 9 numbers in that sample of data actually are below 21. So 9 divided by 18 is 50%, so 21 would be in the 50th percentile. Now, when calculating percentiles, if you get a decimal, round to the nearest whole percentile. But if it comes out to be a whole number, then use that exact whole number as your percentile ranking. Now, for classwork, make a histogram from the given set of data and also use 5 for your bin width. And then determine the percentile ranking for 24 in that set of data that you were given in problem number 1.